So let's discuss about the average power across a capacitor when an AC is applied across it. Let's say we have a capacitor. Let's say its capacitance BC, which is connected across an AC. And let the AC voltage be V equal to V0 sine omega t, where V0 stands for the peak voltage and omega the angular frequency. Clearly, there will be a current flowing through the capacitor and its direction keep on changing. That is, if in the first half cycle, if it is in the clockwise direction, then in the very next half cycle, it will be in the counterclockwise direction. Now, the current in the circuit, let's represent it using I, will be, we have in a capacitive circuit, the current leads the voltage. That is, we have I equal to I0 sine omega t plus pi by 2. That is, in a purely capacitive circuit, current always leads the voltage by a phase of pi by 2. We already discussed this. Now, at any instant, let the power, let's represent power using P. Power at any instant will be the product of voltage and current. Also, we know power is equal to the rate of doing work, or dW by dt, where W stands for the work. So I can write dW by dt equal to, for P I can write dW by dt, for V equal to V0 sine omega t, and for I can write I0 sine omega t plus pi by 2. Clear? Rearranging this, you will get V0 I0 sine omega t. See, sine omega t can also be written as sine pi by 2 plus omega t. That is sine A plus B equal to sine B plus A. But we know sine 90 plus theta, using the identity, we have sine 90 plus theta is always cos theta. So this will be cos omega t. So V0 I0 sine omega t times cos omega t. Now, let me introduce a 2 in here. That is, I multiply this, divide this term with 2 and multiply this term with 2. Sine omega t cos omega t. There will be no change in the equation, because when 2 and 2 get cancelled, the equation is same as before. Clear? Now we have this value. We have sine 2 theta, using identity sine 2 theta is 2 sine theta times cos theta. You can apply this identity in here. So the work on the left side, it is dW equal to, let me take this dt to the right. Before that, this is V0 I0 by 2. This value is actually sine 2 omega t, using this identity. Now I can take this dt to the left, so it will be dt in here. Call this as equation number 1. Now to get the total work, let's say the total work let's represent that as W. We need to integrate it from, see, the variable in here is dt, t. So limit 0 to the complete time period t, V0 I0 by 2 sine 2 omega t dt. All these V0, I0 and 2 are constants, so that I can take that out. 0 by 2 integral 0 to t sine 2 omega t dt. So that will be V0 I0 by 2. Integral of sine is cos. So minus cos 2 omega t, you have to put the constant 2 omega. Now the limit 0 to t. Actually, integral of sine 2 omega t is cos 2 omega t by the constant. Here 2 omega is constant. Clear? Actually, we have integral sine ax dx is actually minus cos ax whole divided by a plus c. This is according to the chain rule. Now I can take this 2 omega out of the brackets. So V0 I0, 2 into 2 omega is 4 omega. Also I can take this negative sign, so minus. Now before putting the upper hand limit, let me change the value of omega. Cos 2 into, instead of this omega, I can write 2 pi by t. Since omega is actually 2 pi divided by t, where t is the time period. I already took this 2 omega out of the brackets. So here it became 4 omega. So there will be no 2 omega in the brackets. Now put the t here. Okay. Now let's put the upper and lower limit. So this is equal to minus V0 I0 by 4 omega. First put the upper limit. So cos 2 into 2 pi is actually 4 pi by t into this t. I can replace it with the capital T. Minus when I put 0 for this t, this whole term becomes 0. So that will be cos 0. Now dW is actually, W is equal to the total work done equal to V0 I0 divided by 4 omega into this t, and t will get cancelled. Now the value of cos 4 pi is actually 1. Minus cos 0 is again 1. So 1 minus 1 will make this term 0. So the total work done is actually 0. Now to get the power, we have the total power or the average power. P average is actually the total work divided by the total time taken. Here the total work is actually 0 by t. It will make the average power 0. So the average power in a purely capacitive circuit is 0. Which means there is actually a voltage and current in the capacitive circuit, but this current gives no power. So this current is called wattless current, like we discussed in the inductive circuit. Clear?